So friends, let's see the third question. What is central limit theorem? Explain its significance in statistics and machine learning. Now, this is also a very fundamental question which you can expect in any of the interview question. The central limit theorem is a very basic fundamental theorem in statistics and probability, right? What it states is the distribution of a sample mean of a random variable will approach a normal distribution as the sample size increases, regardless of the underlying distribution of the population. Now, big words are there. Let's break it down step by step. Okay, so let me draw it a figure and then try to explain. Suppose this is a population distribution. Okay, this is H and this is my frequency. Okay, so this is a proper population distribution, some population distribution. Maybe we know, we don't know, there is some weird type of population distribution. But what if, and there is a mean of this also over here. Okay, suppose there is a mean also over here. What this central limit theorem state is that we do not care what population distribution the sample is coming, but if you are sampling over here, right, let's say I created multiple samples. Okay, so my first sample is sample 1, right, is I'm sampling at this point, 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 right? Okay, and I noted down all the numbers. So my x1, x2, x3, x4, x5, and the corresponding frequency, right? Okay, I sampled. Okay, now similarly I will take multiple samples, so sample n. Okay, now this will be xn1, xn2, something like that, xn, right? And what I do is I will plot a sample statistic. What do you mean by sample statistics? Let's say I am plotting the mean of these samples, the sample means, right? And I'm plotting it over here. If I'm plotting the means of this, if I'm plotting the sample mean, right, over here, then let's say my first sample mean resulted it over here. My second resulted it over here, third resulted it over, fourth resulted, fifth resulted it over. What it is saying is that central limit theorem says is that for a very large sampling, if we do this sampling multiple times, many times, then this particular graph, which is created by the sample statistic, which is sample mean in this particular case, will gain the shape of a normal distribution. That is what it is saying, right? No matter what the distribution is, but if I'm randomly sampling over here and I'm calculating the sample mean of these and I'm drawing a graph out of it, frequency distribution table, frequency distribution out of it, then this will approach normal distribution. And the mean of this for a very large number of samples will approach mu, the population mean. Okay, clear? Let's repeat this, what it is saying. Let's break it down and repeat it. Okay, no matter what the population density is, we do not know what the population density is, we do not care about it, what it is. But if you are sampling from here, if you are sampling, let's say we are sampling 30. In each sample, we have 30 observations. We are sampling from here. And what we are calculating? We are calculating mean, sample mean, right? So for n samples, we have calculated how many? This is the S1 bar, this is the Sn bar. And what we are doing? We are plotting this S1 bar and till S1, Sn bar. What shape of this sample distribution will be? This will be a Gaussian distribution. Okay. And what will be the mean of this sample distribution? What will be the mean? For a very large number of samples, it will approach your population mean. This is what central limit theorem says. Okay, clear? Now, two things to note over here, that the sample size, usually empirically it has been found that it should be greater than 30. Okay, it should be greater than 30. Now why greater than 30? It's more empirically divided. Yeah. And the other thing is that more number of samples you have from the population, the better the chances that this mean, the mean of this normal distribution will approach, let's say this is mean of the sample, this will approach the population mean, right? The better is the chances of that happening. Okay, these are the two things which central limit theorem says. Okay, so here it is saying, and now friends, I hope you understand that what central limit theorem is, right? In simpler terms, CLT states that it will take a large enough sample from any population. The distribution of the mean of all possible samples will approximately normal, regardless of the distribution of the original population. So another thing to note is this is true about any sample statistic. Here we are taking the case of mean, but suppose you are taking sample and you are taking the sample of standard deviation also. That is also a randomly generated variable. Randomly generated what? Because you are doing a random sampling on the population and you are calculating a statistic. What is that a statistic? You are calculating not the mean but the standard deviation. In that particular case, standard deviation will also follow the same thing what mean is following. That particular standard deviation will approach population standard deviation for a very large number of samples. Okay, that's the beauty. So why it is saying? It is saying that the distribution of the sample mean of a random variable will approach a normal distribution as the sample size increases, regardless of the underlying distribution. In case of sample mean, you can remove this and put this any sample statistic, because it's a no. What it is? It's a randomly derived value. Okay, my sample standard deviation is also a randomly derived value, so CLT will be applicable over there as well. Okay, now where the CLT, what is the CLT is used? CLT is used in hypothesis testing, confidence intervals, right? Probably we can show you that. It is also used in regression analysis, right, to justify that whether we should use the t distribution or standard normal distribution. This is used. Okay, let's see a simulation to intuitively understand what it is. Okay, this is the very good simulation web page I found from the Columbia University, right? So it is asking for the seed, and seed I can supply 40 to just random number some. Okay, now choose a distribution type. Now you do not have to tell that it has to be a standard normal Gaussian distribution. I'm taking a skew, right? Let's say I'm taking a skewed distribution. Okay, in that particular case, what will happen? Let me select a sample mean. I've selected a sample mean which is 3. Okay, this is all about population till now. Okay, now select a standard deviation. I selected the standard deviation. Now let me generate the population. The population is generated like this. This is the population, right? Obviously this is not a normal distribution, Gaussian distribution, right? This is a highly right skewed distribution. Now let me generate the samples over here. So my initial sample size is 25 I'm keeping, and number of samples I'm taking 150. Let's see over here and see what is happening over here, right? This is the 25 observations in sample 1, and let me start. You see the dots happening. These are the samples which are being taken, and see how I'm building. And if you see the lower half over here, this is what it is getting built, right? My sample statistic. So in this particular case, it is mean. So I'm building the sample statistic, right? And where I'm taking the sample from? I'm taking the sample from the population distribution, right? How many samples I'm taking? Over here, right? So these are the data points which are samples. Now let's see. Okay, suppose I take a large number of samples over here, okay, and select the number of samples not as 150 but as 1000, okay, and select a sample size 100. 100 is the sample size. Select the number of samples 1000. So in each sample I'm taking 1000, and how many samples I'm taking? 100 maximum. Let's see. And over here also I made it high, and let's see that if it is approaching a normal distribution of you see my sample is almost like my sample distribution, right, which I'm generating from the population, which is not a Gaussian distribution, is approaching the shape of a normal distribution, right? This is what central limit theorem says. Okay. Yeah, this is the same thing. So what we are doing, I just showed you in the other slide also. It's the same thing, right? We are taking multiple x bars and then we are plotting all those x bars, right? And then it is approaching a Gaussian distribution. This is what a central limit theorem says. Okay, so friends, I hope that you understood what the central limit theorem and its significance is. With that being said, I will close it and I will see you all in the next question.